Okay, so get those turned in, and I pass back your other ones to you guys. And we are going to start doing lesson 1 today, so you will need your notes out. And for your notes, okay, well, you'll be on day 1, and then you also need the little graphic organizer color thing that says types of numbers, okay? So you need types of numbers and lesson 1 out of the notes. I think the first thing on the notes says lesson 1 with handout, and then natural numbers or ... Okay? That's what we'll be at today.
Types of numbers?
Yep, types of numbers.
And what?
And then the lesson 1 notes. Okay, so easy stuff here. A number whose value is less than 0 is called a what type of number? Negative number. Okay, 12 and negative 12 is obviously going to be 0. 2/3 times 3/2 is going to be 1. 3. Now, what's the relationship between 2/3 and 3/2? Reciprocal. It's the reciprocal. Good. We're going to get probably 0.15, and then we've done the ACT and these questions. Good. Okay. All right. Today you're going to be I'm going to give you a number, and you're going to be able to classify the number according to which subset of real numbers they belong to. Given a number, students will be able to find the additive and multiplicative inverse. What's inverse mean?
Opposite.
So you're going to find the adding opposite and the multiplying opposite. Okay, hopefully this is all pretty much review right here. We kind of fly through this. Okay, so now yours looks kind of like this. This is how mine look. Your green box is irrational numbers. Okay, so label the small circle natural numbers. The orange circle.
Room to like write things under.
Yeah, you're going to want a little. You're going to need about half of it. If you want to use markers or colored pencils or crayons, you can come up here and get those. Okay. Label the small circle natural, the white circle whole, the yellow circle integers, the red box is rational numbers, and then the green box is irrational. Okay? So the green box is irrational, the red box is rational, and the integer is whole and natural. Okay? Now, who can remember what natural numbers are? What are the natural numbers?
1, 2, 3.
Yeah, 1, 2, 3, 4, 5, all the way up to infinity. Okay, so natural numbers in there. Let's go ahead and do squiggly line, 1, 2, ... squiggly line. Okay, I got that handwriting. It's hard to go on there. But just 1, 2, 3, all the way up. ... means infinity. Now on your, so now flip over to your notes. We're going to kind of bounce back and forth. On your notes, natural numbers, and it has or. Does anybody remember what the other word we have? Counting numbers. We said counting numbers because we can count them on our hands. Okay? 1, 2, 3, 4, 5, 6. Take off a shoe. When you get past 10, you can go past that. Okay? Counting numbers. So then also on your notes, so we said counting numbers. Okay? And then do the squiggly line, the bracket 1, 2, 3 again, ... all the way up. Okay? Now, can I count 4.5 on my hand? No, I mean I could go like this and then like.
If you have like half a finger.
Yeah, if you cut off a finger and then you got half a finger, then you could maybe do it. Okay? But no. Okay? We're going to just go right there and say we can do that. Okay? So that's counting numbers. Now, whole numbers. Your next one, what does whole numbers add?
0.
And just add 0. So whole numbers on your notes is 0 and counting numbers. Okay? And then brackets just going to be 0, 1, 2, 3, ... all the way up to infinity. And then in your graphic organizer, go ahead and do the same thing of adding the brackets 0, 1, 2, ... all the way up. Okay? What's the sign for infinity?
It's a little circle. It's sideways.
Sideways 8. Yep. So you don't need to know it, but just kind of nice that is the infinity proportional, but that's what it is. Okay, integers is going to be what? Negative and positive numbers on a number line. Okay, so we can go ahead and write that down. Negative and positive, or we can say negative and whole numbers, probably the better way. Negative and whole numbers. Okay, and then squiggly line. But what are we going to start with the squiggly line? Is negative 2 the smallest integer?
Negative 1.
Is negative 1 the smallest integer?
Negative 0.5.
What's the
same thing?
How do I see?
It's 0.
Negative whatever.
Negative 2, negative 1, 0, 1, 2, dot, 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 all the way on. It's saying that I could do negative infinity all the way to positive infinity. Okay? Is negative 3.5 a integer? No, because it's not that. Okay? So if you want to, off to the side of these, if you kind of want to make just this right here and make a note of no decimals. Okay? Those are no decimals. Okay? On
All
your
of
notes.
these 3.
Yeah, all 3 of those are no decimals. And then on your organizer, here, dot, 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 negative 2, negative 1, 0, 1, 2, dot, 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 continue it on. Okay? Whatever you do. Okay? Everybody good with me so far? Okay. Now, before we move on, I want to cover the definition of subset, which hopefully in geometry we remember what a subset is, but I want to review it. Does anybody know what a subset is?
It's like all of the numbers that will work.
Okay, so in our world, we have all real numbers, right? We got all these numbers, 4.5, pi, 2, negative 3, those are all real numbers. Subset is a specific group of numbers, a specific group, it doesn't even have to be numbers, but a specific group. So when I talk about the subset of counting numbers, we're only talking about 1, 2, 3, 4, infinity. We're not talking about negatives, we're not talking about 0, we're not talking about decimals, we're not talking about fractions. So subset is a way of saying a group of numbers, a specific group of numbers. Okay? So the subset of counting numbers eliminates 0, negative, decimals, fractions, irrational, rational. It eliminates all those. Okay? Subsets is a specific way of saying a group. Okay? In this class, we have 2 subsets. Boys, girls. We could even go further into say, okay, how many of you are 16? How many of you are 17? How many are 15? How old are you?
16.
Oh, you reached, okay. So we have 16 and 17. Do we have any 15-year-olds? No. So we have 2 subsets of 16 and 17. Okay? Boys and girls. We could classify as plays a fall sport, does not play a fall sport. We could classify as is on the speech team, is not on the speech team. We could classify it a million different ways. Someone that works or someone that doesn't work. Those are all groups of the big group of Algebra 2A. Okay? Does everybody understand subset? Okay? Alright, now we go to rational numbers. Now, think about in English, what does the word rational mean?
It means it makes sense.
It makes sense. So I can explain it. Okay? So if I can explain it, that'll be good later on. But rational, what are rational numbers going to be?
Anything you can make into a fraction.
I can make into a fraction. Okay? But not necessarily just that, something that I know how the decimal ends. So if the decimal repeats or if it terminates. But yes, I can make it into a fraction. Okay? So what are some examples of rational numbers? Well, first off, we can do 1/4. We could say 0.3 repeating. What's another one? There's a million of them. What'd you say? 2/5. You could say 0.138. You could say 3.629. Whatever. Because the decimal terminates or it repeats. That makes sense. The decimal makes sense. Okay? I know what's going to come next. Nothing. It's 8. It ends. I know I'm 0.3 repeating that the next number is always going to be 3. I can make sense of the decimal. Okay? So those are just some examples. And then under rational numbers for your definition, just say numbers with a decimal that terminate, which means end, or repeat. Okay? So the decimals terminate or repeat. I can make sense of them. Rational numbers make sense. Okay? Which just leaves us with irrational numbers, and irrational means you're crazy and you can't explain it. So irrational numbers, and you go ahead and write this down for a definition, the decimal goes on forever. It does not repeat. Okay? Irrational numbers go on forever and they do not repeat. So what are some examples of irrational numbers that we can put on our organizer? Pi. That's the one that everybody likes. Okay? Another one, you can type it in your calculator if you want, square root of 2. Okay? Another one is the letter E, which is similar to pi. The letter E is just like pi. It's another number. Okay, we'll learn about it later. Okay? Euler came up with it right here. Tyrell and Willie did this one. But Euler, the E, 2.718, dot, 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 goes on forever. Okay? You could have negative square root of 5. Okay? What do you notice about 2 and 5? They're both what type of number?
Imperfect squares.
Not perfect. 2 and 5 are not perfect squares.
Imperfect.
Imperfect squares, yes, imperfect squares. So they're prime numbers. Okay? So those are all examples of irrational. And all irrational means that the decimal goes on forever. But now,
That's
square root of negative 1 is I. It's a complex number.
So it doesn't, it's not a real number.
It's not a real number.
So
Okay?
a rational number cannot be negative, or it can be.
Rational number can be negative as long as the decimal terminates or repeats. Yep. And irrational numbers, the decimal goes on, it does not repeat and it goes on forever. Okay? So 0.333, it goes on, 0.3 repeating goes on forever, but I know what it's going to do, so I can tell you what it's going to do. So that's why it's rational. Irrational, I don't know what's going to happen. Okay? Now, all these numbers that I have on the board are what type of numbers?
They are real numbers.
They're real numbers. So at the very top of your paper where it says, where the white line, just say all these numbers are real. Okay? Right now in our mathematical journeys, all we know is real numbers. Later on, we'll get to complex numbers. Maybe some of us know complex numbers, but for right now, everything is real. Okay? Those are our types of numbers. Okay? Now, with this, let's ask some questions. Can a number be both irrational and rational? No, it's got to be one or the other. You got to be a boy or a girl. Okay? You got to be an 11th grader, or you got to be a 10th grader. Yeah, touchy subject, I know. Okay? Touchy subject, whatever. You got to be a boy or a girl. Okay? Okay? I know. So, either one. Now, are all natural numbers rational numbers? Yes. Also think, I can go from small to big. The natural circle is inside the rational box. So yes. Are all rational numbers natural numbers? No, I can't fit something bigger into something that's small. Okay? Are all whole numbers integers? Yes. And all integers are not all natural numbers. Okay? So you can go back and forth from there. Good. Okay? Rational numbers and irrational numbers are the only one that are going to give you decimals. Technically, these all have decimals, but they're all 0.0, right? Okay? Who knows what's going to happen? Okay. Any questions about these subsets of numbers? No. Okay. -5. Now, I want to list all that apply. So -5, give me one number, Sage, or one subset of numbers. Integer. So it is an integer. James, what's another one?
Rational.
It is rational. And then Brandon, what's the last one? All numbers are real. So integer, rational, real. Don't forget real. Okay? All numbers are real. Okay? 25 is going to be what, Grady?
Natural.
It's a natural number or a counting number. Yes, Emily, what else can it be? It can be whole. Weston? Integer. Emma? Real. And then the last one, Logan? Rational. It's going to be all of them. Okay, 0.3333, okay, is what type of number, Coy?
It is a rational number.
It's a rational number and it's also a real number. That's a decimal. Negative square root of 5 we know is what, Gracie?
Irrational.
Irrational and also real. Okay? Classified numbers into their subsets. So I can be a member of more than one subset, right? I don't have to just be in one subset. I can belong to 2 groups. If we were talking about the population of students at Burwell High School, you could classify them by grade or by teacher. You could have athlete or not athlete. So let's just say Sage. Let's talk about Sage. He would be in the subset of 11th grade, football player, basketball player. He'd be on the rodeo if we put that in there. He'd be FFA if we threw that in there. NHS, so on and so forth. Okay? Speech, etc., etc. He could belong to all of those subsets if we were talking about kids and things that they could do at Burwell. Okay? Now we're going to move on to commutative, or property. So on properties, the first property, write down the commutative property. Okay? And, so just write the word commutative. Commutative property is, let's see, Katie, do you know the commutative property? What is it? Switch, so I can switch what around?
So it could be 3.
Can you give me an example?
Like 5 plus 3 plus 3.
So 5 plus 3 equals 3 plus 5. Yeah. It says I could add things in any order. Okay? Or I could what? Multiply. I could do 5 times 3 is equal to 3 times 5. Now I can't subtract because 5 minus 2 is 3. Flip it around, 2 minus 5 is negative 3. So it doesn't work for subtraction. What about division? No. Because 4 divided by 2 is 2, but flip it around, 2 divided by 4 is 1/2. Okay? So commutative property, if you guys want to put an example, you can. If you want to put words, it means I can add or subtract things in any order. Or not add or multiply things in any order. Excuse me. Commutative property, I can flip the way I do it and I get the same answer. Okay? Another way to think about it is, if I drive from Burwell to Ord, that's the same thing as driving from Ord to Burwell. Same thing, I don't change what I do. 5 plus 3 is 8, 3 plus 5 is 8. Good. Okay? Associative property is what? That's your second one. Write down associative.
It'd be like A plus B in parentheses plus B.
So A plus B plus C, put the first 2 guys, and then do A plus B plus C, and throw these guys in parentheses. So it's just saying that, again, I can add things in any order. If I have more than 2, I can change which ones I do first. Because maybe it makes more sense, okay, to add some different things here. Okay, if I have 2, or let's put some bigger numbers. Let's say I have 175 plus 25 plus 398. Okay, what's going to make sense to add first? Yeah, it's going to make sense to do this first. Okay, because I get 200. Okay, but maybe if I had this rearranged different where it went 398 plus 175 plus 25, now I want to add these 2 guys first. Okay, does it work for multiplication as well? Yeah. Okay, to me the associative property and the commutative property are the same thing. Because I can do things in any order. Okay, and I'm going to get the same answer. So I could also have A, B, C. As Michael Jackson would say, it's easy as 1, 2, 3. Okay? It could have any order to multiply or add. Does it work for subtraction?
No.
Does it work for division? No. So if you want to make a note, the commutative property and the associative property are only good for multiplication and for addition. Okay? Same thing, way to think about the associative property. If I say Bodie, Logan, Weston, it's the same thing if I go Weston, Logan, Bodie. Doesn't matter what order I say it in. Okay? Good. Third property, distributive. What's the distributive property say?
So it's like if you have A, B, and C, A times B plus C is equal to A times B plus A times C.
Okay. This is you're going to hear me say a lot this class, don't be a bully. And hopefully if you were a freshman, that's the one thing that sticks with you is don't be a bully. What I do to one thing, I do to both, okay? If I'm going to give a dollar bill, okay, if I'm going to say I'm going to give a dollar bill to both of these guys, I'm not just going to give one to Bodie and say, hey, tough luck, you're not getting one. I got to give one to both of them. I got to be, don't be a bully. So the A goes to both of them, and that's going back all the way to 8th grade, okay? AB plus AC. Distribute. Distribute means to give. All right? We're going to come back to close. We're going to skip close. We'll come back to it. Okay? And I want to go inverse. What's inverse mean? Opposite. So your fourth property is going to be inverse. Okay? Inverse means opposite. And remember when I talked at the beginning, you're going to be able to find the multiplicative inverse and the additive inverse. Okay? So, if I have A plus what
Negative.
equals 0?
Negative.
Negative A. Good. So the additive inverse is just the negative number. It's the opposite of A, right? The opposite, okay? And if I have A times what is going to give me 1?
1 over
No,
A.
1 over A. This is your multiplicative inverse. This is your additive. Additive inverse is there. What do I add to A to get 0? What do I multiply to A to get 1? Multiplicative inverse. Additive inverse. Add the opposite, multiply the opposite. Okay? Do we need to do any examples of those? No. Okay. So that was 4. Now we're on to 5 for the properties. An identity property. Okay? What's identity means like who I am, right? Who I am. So if I have A, what do I have to add to it to get A? 0. And if I have A, what do I have to multiply it to get A? 1. A times 1 is A. A plus 0 is A. Just the identity. How do I get what I have? That should be self-explanatory. Another one that we don't need to write down because it's pretty self-explanatory. The zero product property. Emily, what's zero product property? Yeah, you multiply it by 0. Zero product. Product means a multiplication answer. So 0 times anything is 0. That's what the zero product
So
property
is
is.
inverse and identity only subtract, addition and multiplication too?
Yep. All these properties are just going to be that. Okay? But you got to think about it. Think about the inverse. Inverse, if you have negative A, then you're just going to add positive A. So it's kind of A minus A is subtraction. Adding a negative is the same thing as subtracting. Okay? All right, now that thing we need to come back to is closed. Okay? Is closed. And if someone looks it up in their book, maybe they give us a nice little definition of closed. Okay, I think it's on probably the second.
Oh, it's closure.
Closure, yep, closure. Where's closure at?
Page 3. It's a class.
Page 3. So closure, what is it?
It'd be like A plus B is the real number.
Yep. So A plus B equals real number. That's what closure means. Okay? Now the book likes to ask different questions. Okay, they like to say, is it closed under whole numbers? Okay? So means by closed by whole numbers is do I get a whole number as an answer? So if I do 3 plus negative 7, am I closed under real numbers?
Yes.
Yes, because I get what? Negative 4 is my answer, right? Am I closed under whole numbers though? No. Am I closed under integers? Yes. Okay? So it's all about what do I get for an answer. Closed is, does my answer fit in the subset they want me to be in? That might be the thing to write down. The answer is in the subset of numbers they want. The answer is in the subset of numbers they want to be closed. Okay? Closed means it fits in there. Okay. What I'd like you guys to do with a partner before we start homework is on page 4, I want you to do A through K with a partner. Okay? This is not part of homework. This is just to kind of make sure we understood the lesson. A through K with a partner. Okay? And then when you get done, you and your partner will bring it up to me to look at, and then you can start homework. If we have an odd number, we can do a group of 3.
Okay, I already got 4.
I think we're even. We have an even number.
Yeah, we have.